Welcome back, viewers. Today, we have an intriguing case study to delve into, the OceanGate Titan project. In this video, we'll explore the product development journey of the Titan submersible by OceanGate and examine the project management perspective to understand what went wrong. So, grab your notebooks as we dive deep into the OceanGate Titan project. The OceanGate Titan was a revolutionary underwater exploration vehicle that aimed to push the boundaries of oceanic research. With a team of talented engineers, designers, and scientists, the project set out to create an advanced and state-of-the-art submersible. Before we dive in any further, let us understand who made this submersible Titan and why was it made for. OceanGate Incorporated. OceanGate is a privately owned U.S. company in Everett, Washington, that provides crewed submersibles for tourism, industry, research, and exploration. The company was founded in 2009 by Stockton Rush and Guillermo Sonlane. The company acquired a submersible vessel, Antipodes, and later built two of its own, Cyclops 1 and Titan. A submersible is an underwater craft which needs to be transported and supported by a surface vessel or platform. This distinguishes submersibles from submarines, which are self-supporting and capable of independent operation. Antipodes is a steel-hulled submersible capable of reaching depths of 1,000 feet, 300 meters, underwater. Cyclops 1 is a 5-person steel-hulled submersible capable of diving up to 500 meters, 1,640 feet, underwater. Titan was the second submersible designed and built by OceanGate, with an intended maximum depth of 4,000 meters, 13,000 feet. Co-founder Stockton Rush had built his fortune by investing his inheritance in tech companies. Rush's experience and research led him to believe that he had discovered an unmet business opportunity to expand the market of private ocean exploration. OceanGate's Titan was used for several survey expeditions of the Titanic wreckage site, starting in 2021. Initial plans for the Titanic expeditions were announced in 2017, with the first trip scheduled for 2018. The cost of a ticket on Titan to view Titanic had risen to $125,000 by 2019. The first voyage to Titanic was delayed to May 2021 due to the COVID-19 pandemic in the United States. Canadian-flagged AHTS Horizon Arctic served as the surface support vessel for the 2021 season. 8 persons visited the Titanic on the Titan in 2022, 21 of whom were non-staff passengers. Horizon Arctic again served as the support vessel for the 2022 dives. In 2021, OceanGate began taking paying tourists in the Titan to visit the wreck of the Titanic. As of 2022, the price to be a passenger on an OceanGate expedition to the Titanic shipwreck was $250,000 per person. Design and construction of Titan. OceanGate began developing a composite carbon fiber and titanium-hulled submersible in collaboration with the UW's Applied Physics Lab, APL, in 2013, tentatively named Cyclops 2. OceanGate signed a contract with Spencer Composites in January 2017 for the carbon composite cylinder. Spencer Composites was given challenging performance targets for Cyclops 2, which was meant to withstand 6,600 pounds per square inch, 46 megapascals, 450 atmospheres, working surface pressure with a factor of safety of 2.25 times for its intended maximum depth of 4,000 meters, 13,120 feet, and provided 6 weeks to complete the design. In March 2018, Cyclops 2 was renamed to Titan. The entire pressure vessel consisted of 2 titanium hemispheres, 2 matching titanium interface rings, and the carbon fiber wound cylinder. Titan was equipped with a real-time acoustic monitoring system that could detect the onset of buckling in the carbon fiber hull prior to catastrophic failure. The entire pressure vessel consisted of 2 titanium hemispheres, 2 matching titanium interface rings, and the 142 centimeters, 56 internal diameter, 2.4 meter long, 7.9 feet, carbon fiber wound cylinder, the largest such device ever built for use in a crewed submersible. Overall, the Titan was 670 centimeters times 280 centimeters times 250 centimeters, 22.0 feet times 9.2 feet times 8.2 feet, and weighed 9,525 kilograms, 21,000 pounds, with a maximum payload of 685 kilograms, 1,510 pounds. It moved using 4 electric thrusters, arrayed 2 horizontal and 2 vertical. Titan carried sufficient oxygen to sustain a full complement of 5 people for 96 hours. It was controlled with a modified game controller, similar to Cyclops 1. Limitations of Titan. The hatch of Titan was closed and bolted from the outside, and there was no way to open it from inside the vessel. There was no onboard location system, and the support ship monitored the position of Titan relative to its target and sent text messages to Titan providing distances and directions. Titan was not equipped with an emergency locator beacon. Testing and inspection of Titan. A 1/3 scale model of the Cyclops 2 pressure vessel was built and tested at the University of Washington Applied Physics Laboratory. Initial shallow dive testing with a crew was conducted in Puget Sound. Testing of Titan without a crew to 4,000 meters was performed in 2018 to validate the design, followed by a statement that a crew of 4 had set a record by descending in Titan to 3,760 meters in April 2019. After the tests were completed in January 2020, the hull of Titan began showing signs of cyclic fatigue and the craft was derated to 3,000 meters. Controversies surrounding Titan. David Lockridge, the OceanGate Director of Marine Operations, filed a quality control report in January 2018 in which he stated that no non-destructive testing of the carbon fiber hull had taken place to check for voids and delaminating which could compromise the hull's strength. Lockridge was dismissed from his position after he reiterated his concerns and added he would refuse to allow crude testing without a hull scan. OceanGate filed a lawsuit against Lockridge that June, accusing him of improperly sharing proprietary trade secrets and fraudulently manufacturing a reason to dismiss him. Journalist David Pogue noted that the surface support vessel lost track of the Titan for about 5 hours during his expedition to view the Titanic in 2022. Mike Rice confirmed the submersible lost contact on each of his 4 dives and said that seems to be just something baked into the system. During one dive, it took 3 hours to locate the Titanic, despite landing only 460 meters from the wreck. Based on the above product development case study of the OceanGate Titan project, here are some project management lessons that we can learn to focus in our project work. Setting clear project objectives. Clearly define the project objectives from the beginning to ensure a shared understanding among the team members and stakeholders. In this case, the objective was to create an advanced submersible for underwater exploration. Proper stakeholder communication. Maintain effective communication with stakeholders throughout the project, providing regular updates and addressing any concerns or issues that arise. The story mentions controversies and communication breakdowns that occurred, which could have been mitigated with better stakeholder communication. Quality control and testing. Implement thorough quality control measures and testing procedures to ensure the reliability and safety of the project deliverables. In this case, there were concerns raised about the carbon fiber hull, highlighting the importance of conducting proper non-destructive testing to identify potential weaknesses. Risk management. Identify and manage project risks proactively. The story mentions issues such as losing track of the submersible and difficulty locating the Titanic wreckage, indicating a lack of robust risk management practices. Developing contingency plans and addressing potential risks up front can help minimize disruptions during project execution. Project scheduling and timeline management. Set realistic schedules and manage project timelines effectively. The case study mentioned delays in the first voyage due to the COVID-19 pandemic, emphasizing the need to consider external factors and adjust project schedules accordingly. Also, Spencer Composites was given targets to deliver the carbon composite cylinder that could have been unrealistic. Let us conclude. The OceanGate Titan project serves as a valuable case study, highlighting the importance of capturing the important project processes in product development. By learning from the project's shortcomings and implementing best practices, future endeavors can avoid similar pitfalls and achieve successful outcomes. That brings us to the end of our analysis of the OceanGate Titan project. Remember, effective project management is a key ingredient for success in any venture. If you enjoyed this case study, be sure to hit the like button, subscribe to our channel, and leave your thoughts in the comments section below. Until next time, keep managing your projects with precision and care. Goodbye.